Okay, for question number 1, kata a charge Q is located at the origin, while elliptical charge is located on the x-axis at x equals to 0.75. The third charge, okay, so dia kata ada dua charge ya. Satu tu dekat origin, satu tu dekat 0.75. The third charge, the magnitude is twice located on the x-axis at such a place that the net electrostatic force on the origin is double. Its direction remain unchanged. Where should be the third charge located? Okay, this one to answer this kind of question, you really have to draw. Ini kamu, you have to think a little bit. So, dia kata the first charge tu dekat origin, saya dah lukis previously, saya just nak tunjuk ya. So, bila saya lukis, make sure I always try to represent the sign convention. The positive and negative senang nanti nak tengok. So, macam itu saya terus letaklah dia ambil positif. And then yang ni position ni, which is at x equals to 0. The second one is when x is equals to 0.75. So this one, I think the units in meter kot. Yeah, it's in meter. So I just write down the unit. So 0.75 meter. And then the third charge will be somewhere along the axis. Okay, and then they want to show that the force actually doubles. Okay. The force on the charge at the origin doubles, but the direction remain unchanged. So obviously, if it is on the same axis, it can be located over here. It's on the left hand side or on the right hand side. Okay, but the keyword there is that the direction remain unchanged. So if you ignore this one first, we try to determine the direction of force there. So let's say this is my Q1 and Q2. So that means this is would be sorry, because this one is repulsive force equal charge, equal like charges. So it will be F on 1 by 2 on that direction. So if I put the second charge over here, then the direction of force will be pushing in this direction. Right, so if it is double, then the magnitude needs to be lots bigger, and then the resultant will be to the right. So tak setuju dengan soalan lah. So instead I have to put it somewhere over here. When it's over there, then we have to calculate. Okay. So we just assume it's over here, and the distance is D. We assume first the position is over there, and then the distance is D. Okay, now if you want to solve, it says that the force is actually double at 1. If I put it over there, then it produces another force, repulsive force. Then this force direction will be in that direction as well. This will be F on 1 by 3. So that one is Q3 lah. So if I want to write down this equation, I have two force, F12 and F13, both in the same direction. And the magnitude of the resultant is twice of the force initial to F12. Okay, I hope by now kamu dah try lah buat at least kamu dah try, and then tengoklah macam mana. So if I want to solve this one, I substitute KQQ over R square, okay, common formula lah for F. I just write down the formula over here in case you forgot. F equals to KQQ over R square. This is the formula for force. So that means this will be KQ1-Q2. Okay, since Q1 and Q2 actually the magnitude is the same, QQ, so I just put as QQ over R squared. Initially, the distance between 1 and 2 is 0.75 meter, so that will be 0.5 meters squared. And then F13 is between 1 and 3, which is KQ1. Q3 is 2Q, and then the distance is D squared. Okay, this would be similar to the initial one, QQ over 0.75 squared. Okay. So this whole thing and this whole thing is quite similar, except this one got 2. So I can bring the whole thing over here to the other side, it becomes 1. Right, 2 minus 1 is 1, right? So it becomes KQQ over 0.75 squared, and this one KQ2Q over D squared. You can cancel out the K and Q all together. So you're left with 2 over d square equals to 1 over 0.75 square. Okay, you guys can follow or not? Up until this part. You guys okay? So if I solve this one, d here, I will get d equals to plus minus 1.06. You can press your calculator, you should get this answer. Okay, and the plus minus means it indicates the direction actually. But if I want to get like the same direction, the net force will be the same direction, then it will be in that direction. So in a way, my d here will be equals to 1.06 meter. So slightly longer compared to the initial Q1 and Q2. So it's behind that. Okay. I can write down the final answer as the third charge should be okay. Okay. Should be 1.06 meter to the right of the origin. Okay, so biasakan tulis final answer like this. Okay, tulis balik. You just have to write the final answer and then you just ignore kalau ada negatif. Tengok situation lah. In this case, yang negatif kita ignore. Lalu kita cakap the distance is 1.06 meter to the right of the origin. Position tu penting. But the question asks you to find distance. Okay, and then for question B, dia kata this one is question 1B. In a vacuum, a proton is moving parallel to uniform electric field that is directed along the x-axis. Positive, right? Dia macam confusing. Along the positive x-axis, the proton starts with a velocity of 2.5 times 10 to the power of 4 and accelerates in the same direction as the electric field, which has the value of 2.3 times 10 to the power of 3 Newton per Coulomb. Find the speed and the state direction of the proton when its displacement is 2 millimeter from the starting point. Okay, again, you have to draw a situation like this. So you need actually combination with the previous semester as well, because you have to solve using linear motion equation afterwards. But first you have to find A first. So you have to determine the direction of force and so on. So macam biasa, draw the punya charge. This one adalah proton, so dia adalah positif. So circle, draw positive, okay. And then dia kata this proton is moving parallel to uniform electric field. So let's say if my electric field is to the right, let's say memang kita assume ke kanan lah kan. And then the punya velocity also to the right, parallel. Okay. And then the proton start with a velocity of 2.5 times 10 to the power of 4. That one will be your U, the initial velocity. And accelerates in the same direction as the electric field. Okay, so kalau dia accelerate the same direction with the electric field, that means kamu punya force pun in the same direction lah. If the values for electric field, E is equals to 2.3 times 10 to the power of 3 Newton per Coulomb, and they want to find the speed and state the direction of the proton when its displacement, dia kata bila displacement tu S2 after 2 times 10 to the power of negative 3 meter. So if you notice, I put the one that I have to calculate using linear motion equations, so I put on the right hand side. Yang kita pakai untuk semester ni, I put on the left hand side. Okay, they give you the mass of proton, which is equal to 1.67 times 10 negative 27. And the proton charge is E, so that means the Q will be equals to E lah, which is 1.6 times 10 negative 19 Coulomb elementary charge. Okay, so based on the diagram here, okay, I can write down that F equals to an A. You only have one force pen. And the only force acting here will be the electric force. So E is equals to F over Q, if you guys still remember. write down over here, E equals to F over Q. This is from the definition of electric field. So F there is equals to QE. Because they give you E, so you have to use this equation. So I can substitute inside here, it becomes QE equals to MA. Since we are talking about the proton just now, the charge is equals to E, E is E, M is mass of proton, A is the one that we want to find first, and before we apply on this second part. Elementary charge is 1.6 times 10 negative 19, 2.3 times 10 to the power of 3 for electric field, 1.67 times 10 negative 27, A. If you calculate, you get A is equal to 2.204. Okay. That is for the first part. Okay, we haven't finished answering the question. The question actually wanting to find the speed and direction. So now you have U, S, and A, and you want to find the final velocity. Okay, after it's traveled 2 times 10 negative 3. So you can apply V squared equals to U squared plus, if you guys still remember, 2AS. So the V here is the one that we want to find. So V might have to do smaller, or as I will fit everything. 2.5 times 10 to the power of 4. This one is square. A is 2.204. S is equals to 2 times 10 negative 3. Okay. You guys can see that. So in square root, again, press your calculator. So I pressed it before. So to save you some time, the V is equals to 2.97 times 10 to the power of 6. ms minus 1. Okay. And you have to state the direction as well. So direction to the right. Okay, based on the diagram above, or you can state that the direction of velocity is in the same direction with the electric field. Okay. But if you draw it like this, then you can easily state that it's to the right lah. Okay, any question for question number 1? Ada soalan tak for question number 1? Okay, so question number 1 is actually you have to think a little bit lah, and then you have to connect with the previous knowledge, especially yang this 1B tu. Yang 1A tu, that one you have to draw, and then you have to solve. If there's no question, we move on to the next one, which is question number 2. Question number 2 is about capacitor. Okay, dia kata figure 1 above shows the graph of current against time during a discharging process of a capacitor through a resistor 2 mega ohm. Calculate the capacitance of the capacitor and the time constant. Capacitance of the capacitor and the time. So they want to find C and tau. And then the time taken to a second question. Okay. Okay, they give you a questions like this. If they give you a graph, most likely you have to use the equation. So the first thing first, you have to determine this one is charging or discharging. So here it states that it is discharging, but even if it does, even it's not stated, you can see from the graph that the current actually decreasing indicates that this one is discharging. So if the shape is normal like this, so I assume like this is the normal exponential graph. So equation that you have to use is the normal one lah. Yang tak normal tu the one that you have to 1 minus exponential. So discharging, you have to use this equation. Okay. Now from the graph, okay, they give you critical information like this one. Okay. So it state that when the I is equals to I0 over E2, bila I itu sama dengan I0 over E2, your time is equals to 10. So then C. R is given, which is 2 mega ohms. So I can write down this one as 2 mega ohms. Okay, from this equation itself, you can find the capacitance rate, right? But you have to do longs. Huh? Let's see, capacitance C. Okay. So if I cancel out I, then I can take ln on both sides. So this one becomes 1 over E square, right? So it will be, you can write down as ln 1 minus, because this one is 1 over, right? So ln 1 minus ln E square equals 2. And this one, I can take ln E, and then I can bring the whole thing down to the front. Negative 10 over 2 times 10 negative 6 capacitance. So this one, the rest is mathematics. Okay. So ln 1 is equals to 0. Okay. And then ln E square to 2 you can bring to the front. And then ln E2 becomes 1. Okay, like this one, it becomes 1 now. So now you're left with 10 over 2 times 10 negative 6C. So if I bring to the other side, positive, so negative cancel out, become positive. And then this one you will have 10 divided by 4 times 10 negative 6. So it's the capacitance. So this one you will get 10. 2.5 times 10 negative 6. Yeah, I think this one is mega, right? So mega should be positive. I wrote this one as negative. It should be positive over here. Okay, now it makes sense. So I will get 2.5 times 10 negative 6. You can write down in terms of micron, but you don't have to. No? You can leave it as it is. So normally I will leave it as it is. So this one is for question A, but still, we haven't finished answering the question. Still get another one, which is the tau. So to find tau is basically R times C. We found the C just now. So 2 times 10 to the power of 6, which is the resistor. 2.5 times 10 to the power of negative 6 for the capacitance. So this one you should get 2 times 2.5, you get 5 seconds. Okay. Oops. This one is for question number 2A. For 2B, they ask you to find the time taken for the current to decrease to half of its maximum value. So basically, they ask you to find what happened, when is the time when I is now decreased to half. So based on this equation up here, okay, maybe I can do it on the new page instead. Okay, because when I now half of the maximum value, so I naught over 2 equals to I naught exponent negative t over 5. Just now we already calculated the tau, right? So RC is equals to tau, and just change this one to tau. That was 5 seconds. Cancel out the I. So again, this one becomes ln 1 minus ln 2. And this one is negative t over 5 ln e. Okay. Ln 1 is equals to 0. Negative cancel out. So it becomes 5 times ln 2, which is equals to 3.466. I can write down as 3.47 seconds. That one is for question number 2. Okay, so if there's no question, we move on to the next one, which is question number 3. Okay. Question number 3, a resistor made of a carbon rod has a uniform cross-sectional area of 5 millimeters squared. Now the potential difference is 15 volts applied across the ends of the rod. The rod carries a current of 4 milliamperes. So basically, the apply potential over here, which is close to 15 volts. Okay, so I can write this one as area equals to 5 millimeter square. So 5 times 10 negative 3, right? But because that one is square times 2 negative 6 meter square, I change straight away to meter. When the potential difference V equals to 15 volt applied across the end of the rod carries a current I equals to 4 milliampere. And then the resistivity of the carbon rho is equals to 3.5 times 10 negative 5 ohm meter. We asked you to calculate the resistance of the rod. Okay, so first thing first, you can calculate resistance because you already have V and I. Actually, you can straight away use the ohms law. You can calculate R. V equals to IR, R equals to V over I. So voltage is 15, current is 4 milliampere. So you will get R to be equals to 3750 ohm. Okay, you can always double check the answer there. Okay, then question number 2, they ask you to find the length of the rod. Okay, so if you want to relate with the dimension, you have to relate with the resistivity equation. So rho is equals to RA over L. Okay, that means your L, if I rearrange, becomes RA over rho. R is equal to 3750. A is equals to 5 times 10 negative 6. Rho is equals to 3.5 times 10 negative 5. I hope you guys can hear me. So this one, I got 535.71. Because everything is in SI unit, so final answer will be meter. Let's for question 3A. Straightforward, tak masalah. The 3B, the battery of EMF 15 volt has a terminal voltage of 11.6 when connected to an external load resistor R. Okay. So if 12.5 watt is delivered, calculate the resistance R and the internal resistance of the battery. Okay, so the 12.5 is actually the power. So battery, EMF, so this one ada terminal voltage tu, so immediately kamu tahu, and this one actually involved with the internal resistance as well. So 15 volt is the EMF, terminal voltage is 11.6, we're connected to a external load resistor R, power is equals to 12.5 watt. Calculate the resistance R. You do have the V terminal and power, so you can use formula that relates P and V. You know that P is equals to IV or I squared R, and another one is P is equals to V squared over R. Okay, kalau kamu tak nampak, you can do that I squared R, and then you can substitute inside the I ni, and then you should get this. Okay? Or alternatively, from P equals to IV, okay, and substitute I ni with V equals to R, so I tu sama dengan V over R, so V square over R. Okay, kalau boleh hafal lagi senang lah. Okay, so I want to find R, therefore R is equals to V squared. Okay, you have to use the V terminal. That's about yang EMF tu the supplied one, yang kita dapat tu hanyalah terminal lah. So yang hasilkan power is the terminal one. 12.5 watt, sorry. So this one I got 10.76 ohm. Okay, this one for question B1. Okay, for B2, they ask you to find the internal resistance of the battery. Okay, so to do this, you can use the formula of internal resistance. EMF equals to terminal voltage plus IR. And remember, I here you don't have yet. You can calculate separately. Okay, you know that P is equals to I squared R. Kalau kamu nak masukkan terus pun boleh. That means I here is equals to P over R square root. Okay, macam betul. So this one will be 15 equals to terminal voltage plus I tadi jadi square root of P over R. P is 12.5. R kita dah kira capital R 10.76. Then small r. So they want to find the small r2. So 15 minus 11.6. Okay. I got here is 3.15. Boom. Just recheck the calculation, or you can calculate the square root first, which is 1.08, and then you can solve for 15 minus 11.6 divided by 1.08. Should get 3.15 ohm. Okay, that was for 2. Sorry, for 2 lah. Okay, the next one is question. What's the here? Question 3C. Oh, ada satu question 3 tu panjang, dia ada sampai C. Okay, question 3C ni, like I told before previously, the first thing that you get, once you get the questions, basically you have to highlight I1, I2 dan I3. Itu kalau saya lah. So basically I1 tu cover from there, I2 tu cover from there to there, and then I3 cover from there to there. Okay. And then obviously you have to determine the loop direction, because current direction is given. Now you want to determine the loop direction. Loop direction, normally I will follow the biggest EMF. So EMF, the biggest one is 18. So I'm going to follow that direction. So that means loop direction upwards dekat center tu. So kalau kat center tu upwards, dekat bawah tu to the right lah. On the left tu downwards, and dekat belah atas tu to the left. Okay, that's the idea. And then the same goes to the other side too. Loop number 2 tu, I'm going to follow yang middle part tu, saya akan ikut dia, and then it will become something that looks like this. And then you have to pick a junction. I pick this one, and then you can straight away apply the first rule. The first rule states that I in is equals to I out. Okay. From this one, if I take the I1, actually I1 pun going in. I1 going in, I2 going in, I3 going out. Kalau kamu letak dia dekat-dekat, kamu nampak obvious lah. Kalau dia jauh tu, maybe kamu nak tengok sikit. So I1 and I2 is going in, so it becomes I1 plus I2 equals to I out, which is I3. So this one becomes your first equation. Yeah, second equation, from the first loop, we can apply summation of EMF equals to summation of IR. Okay, for the first loop, ada 2 EMF, right? So if you follow the loop direction, 18 is positive because it goes out from the positive terminal, and then this one is positive as well because it goes out from the positive terminal as well. So it becomes 18 plus 12. And then for the resistor, loop direction to the right, current direction to the left, so this one becomes negative AI1. Okay, loop direction to the right, current direction to the left, opposite direction kan, so the negative. Yeah, I2 pula, for this resistor, I2 going up, loop direction going up, same direction, so positive for I2. Okay, this one is for the second one. And then for the third one, actually this one you can write down straight away, that one is 30. Now for the third equation, it will be EMF ada 2. This one is positive 18, tapi dekat sini negative sebab dia goes out from the negative terminal. So it will be 18 minus 2 ke 12 tu 2. Saya check soalan ni. 2. Dua lah. 2. Nampak macam so ada conteng tu, confuse. Okay, 18 minus 2 is equals to negative. Sorry, ni tak check lagi. So kita ada 2 resistor. So you expect to have 2 variables over there lah. So this one will be I3 tu current dengan loop same direction, is it? I3 to the left, loop to the left, so positive 6I3. And this one loop direction upwards, current direction upwards, so same direction again. This one is positive 4I2. So normally before I press the calculator, I would like to rearrange lah. Banyak cara nak rearrange. The easiest one maybe kamu buat macam table lah. I'm not actually going to draw the table, but you can imagine that this one is a table itself. So I1, I2, I3, and then kita ada variables, which is yang tak ada variable tu lah, constant tu. So for the first equation tu, so I can write down I1 to positive 1. Ini positif kan, I2 tu positif juga. So kalau kamu tak nampak, kamu kena buat lah, kamu kena rearrange, kamu bawa ke kiri. Okay, so semua I ni kamu letak belah kiri, dan semua pemalas kamu letak belah kanan. Same goes with this one. Kalau kamu nampak, kamu boleh buat straight away lah. So I2 is positive as well. Okay, I3 you have to bring to the left, so that one becomes negative. Dia tak ada variables, so dia tak ada constant, so dia jadi 0. Equation number 2, yang 18 tambah 12 tu adalah 30. So that one is 30. So I1 is negative 8, I2 is positive 4, I3 is 0. Then the last one too will be 18 minus 2, which is 16. I1 is 0, I2 is 4, I3 is 6. Positive, positive. So now you just have to press the calculator. Make sure you guys try to press. So calculator saya line sedikit, so line sikit lah. Okay. So press 1, 1, 21, 0, 28, 4, 0, 30, 0, 4, 6, 16. Okay, I will get I1. Kalau calculator saya ni kan dapat pecahan, dia tak boleh tukar, kena tukar manually afterwards. So the first one will be correspond to I1, second one is I2. Ada negatif, biarkan saja. Okay, now I have to press it manually. So this one becomes negative 2.26 or 27 ampere. 2.96 ampere. So for those yang macam dah buat kan, you guys can check lah kalau kamu betul-betul ke tak, and then maybe you can mark 0.69 ampere. Okay, so in this case maybe saya tunjuk markah dia. So this one is negative. So markah given for this question, if you do the equation correctly, you get concept 1, concept 2, and then concept 3. Now final answer tu, yang calculation tu dia tak ada markah, straight away the final answer. So it will be jawapan unit 1, jawapan unit 1, jawapan unit 1. So total marks is 6. Maybe you can try to mark lah. Yang atas tu nak tengok bukan markah dia. Kita go through sekejap kot. So atas ni saya tak go through the markah, just go through for one. Okay. Question number 1 tadi, akan apply concept correctly, which is pasal yang ni kan, kita satu markah, antrian satu markah, find the answer dengan unit satu markah. Okay. Yang B tu, konsep kamu apply, especially yang dekat sini lah. Maka konsep tu kalau kamu tak apply, kalau kamu tak tulis, kalau jawapan akhir betul, dia still dapat macam hidden. Maksudnya dia assume kamu buat betul lah. Dia kamu tak tulis. Masalahnya kalau kamu salah. Kalau kamu salah, then kamu tinggal markah banyak. Kalau kamu tak tulis. So might as well kamu tulis macam ni kan. Kamu tulis markah, formula tu kamu dapat markah konsep. Yang ni ada marker direction. So let's sum up over there. Okay, and then question number 2 pula. Kita gantian 8 unit 1 markah. Yang 5 second tu 8 unit 1 markah. Yang ni pendek dia terus GJU1. Itu markah ni. Question number 3. Itu pendek juga GJU1. Itu pendek GJU1. Maksudnya the whole thing tu 1 markah je. Same goes with this one. GJU1. Okay, yang ni je ada gantian. And then final answer tu this one. Okay, that one's for question number 3. Moving on to the next one, which is question number 4. Better. Figure 3 above shows a model of device to generate electricity from C waves. The coil is fixed to a concrete block. The magnet can move freely inside the coil. The average vertical component of the electric field at the strike of the magnet through the coil varies at a maximum 0.035 Ts. The coil has a radius of 5 cm, resistance of 6.7. Calculate the maximum current in the coil. Tadi soalan tadi ada satu lagi soalan perasan. C2 tu dia kata find the potential difference between points P and Q. Okay, we finish up this one first. So yang this one yang C2 tu you want to find between P and Q, right? So between P and Q, so normally kalau saya I'm gonna do like saya bayangkan saya tengah daripada berjalan daripada Q ke P tu. So bila saya jalan, as I go across the EMF power supply, you gain potential. So tambah 18. Okay. Bila dia lalu resistance, potential will be dropped by IR. Okay, kita cuba selesaikan. So this one you get, bila dia lalu naik atas tu, dapat positif 18, lalu EMF tadi. Bila dia lalu dekat resistor tu, actually kamu kena letak dia sebagai IR lah. So R ni correspond to R 4 ohm, yang I tu I2. So becomes 18 minus I2 is 2.96. R is 4. Okay. So you should get 6.16 volt. Okay, maka kalau ini tak payahlah. Mesti satu maka jadi dekat final answer. Okay, and then yang tadi tu kan, kalau ada negatif tu kan biar je. Contohnya tadi get negative 2.27, just leave it as it is. Maksud negatif tu, direction of current tu actually opposite daripada initial assumption. So initial assumption contohnya I1 tadi ke atas kan, kat sini. Sebenarnya yang sepatutnya dia ke bawah, tapi dia tak tanya pun, so you don't have to bother with that. Back to question number 4A. Okay, this one, they give you a few information. They want to find the maximum current in the coil. So the idea is that if you can find the maximum induced EMF, then I can use I can apply Ohm's law to find the induced current. So to do that, I have to take out the information first. Okay, the tricky part is the 0.0352. Okay, but if you look carefully at the unit there, it's actually Tesla per second, which correspond to change in magnetic field per second. So that one is actually dBdt. So if you write it down as dBdt, it becomes much more simpler. Senang lah. The coil has a radius, so radius initially is 5 cm. Radius doesn't change, so memang sampai dB lah. So you can straight away calculate the area, which is pi r squared. If you calculate this one, you should get 7.9 times 10 negative 3 meters squared. Resistance is given 6.7 times 10 negative 5. Calculate the maximum current in the coil. So the idea is that you want to apply Faraday's law first, dphi over dt. Okay. So because I just want to find the magnitude, I ignore the negative part too for this one. So phi is equals to BA cos theta, right? So d over dt, BA cos theta, sorry, cos phi, sorry, cos theta lah. Confused. So obviously kalau kamu straight away pakai formula which is dB over dt tu pun boleh, tapi saya biasa buat step by step lah. So we know that the one that is changing is the magnetic field. So I can leave magnetic field inside dB dt tu. Yang lain tu semua saya bawa ke depan. So it becomes A cos theta. Okay, and then theta is actually angle between A and B. In this case, it will be 0. So theta, sorry, EMF now becomes A is equals to 7.9 times 10 to the power of negative 3. 1 dB dt is equals to 0.035. And if you press your calculator, you should get 2.8 times 10 negative 4. So this one is your EMF, okay? But the question wants to find the current, so you can relate using Ohm's law, V equals to IR. So I is equals to 2.8 times 10 negative 4 EMF divided by resistance, which is 6.7 times 10 negative 5. So this one you should get 4.1 ampere. Okay, that's it. Okay, so in terms of marking, you calculate the area, you get 1 mark. And then if you do substitution over here correctly, you get 1 mark. Final answer, sorry, substitute one more time over here, 1 more mark. Final answer we need 1 mark. Okay, so total of 4 marks. And then the next question, question number 4B. Okay, they give you a diagram like this, straight away kamu boleh agak lah. So this one actually involved dengan BL sin theta, right? You nampak straight away. So maybe I can write down BLV sin theta. Question number 1, they ask you to determine the direction of induced current in the metal rod. Okay, you have to use right hand rule tu. Kamu pakai slide rule kan. So kamu move your fingers tu into the page, or the 4 fingers is into the page, following the direction of magnetic field ke dalam. So you want to push direction of V tu, kamu punya palm tu in the direction of V. So in a way, your thumb will be outwards. Okay, kamu tengok balik lah. Kita dapat something like that. Fingers into the page, thumb downwards. Sorry, saya sudah confused. Okay, salah lukis. Kamu punya fingers into the page, and then kamu punya thumb to actually direction of V. Okay, this one correct. So your palm, punya palm tu kat atas lah. Okay, that one will be the direction of current, I. Kalau electron, opposite kan, backslap. Kalau yang positif kat atas lah, current outwards. So here you can say, inside the metal rod, the direction is outwards. So question number 2, dia kata calculate the EMF across the metal rod if it moves through the magnetic field at a speed of 2.5. Now they give you all the informations. They just want you to calculate this. Solve lah. B is equals to 0.85 times 10 negative 3. Length is 25 centimeter, 0.25 meter. V is 2.5 meter per second. Okay, sin theta, theta is the angle between V and B. V dia ke kanan, B dia into the page. So that one is 90 degrees. So theta is equals to 90 degrees. So you have to be careful with the length there. Just have to reread the questions. Metal rod of length 25 centimeter. And then And so you have to choose the length of the metal rod, so 25 centimeters. So here, P is equals to 0.85, 0.25, 2.5, sine 90 degrees. So sine 90 degrees is 1, so we left with 2.5, 125, 0.85 is equal to negative 3, but here is 5.3, 1, times 10 negative 4 volts. Okay, last question for this one, question number 3. Vector state 2 ways to increase the induced current without changing the metal rod. Okay, so obviously you have to use this equation, so any quantity that changes over here will result in increase in increase in EMF. So if you want to increase the length, basically you change the rod, so that one cannot. So you can increase B and V. Increase magnetic field, or you can increase velocity. Okay, so that one is 1 mark each. Okay, yang atas tadi maka dia tak banyak sangat, dia ada konsep kat sini 1, rangkaian 1, jawapan unit 1. Okay, yang tadi tu jawapan saja 1. Okay, let's for question number 4.